Hello everyone. So today we will be covering the practical aspect of ARP as an address resolution protocol. Okay, how does it work? I'll show you the exact packet flow as in how the packet flow of address resolution protocol works. Okay, so here you can see on my screen that I have my PC1. Okay, I have my PC2 and I have my PC3, and we're going to see how packet flow works, okay, and how they'll communicate with each other. Here I wrote the MAC address of PC1 as AA, okay, this is AB, this is 10.1, 192.168.10.1, this is 10.2, this is 10.3, a default gateway. Okay, for here, okay, it's 20.3, okay, and AC is the MAC address, and this is the default gateway for this side, 20.1. Okay, so let's get started. Okay, so basically what happened that first a PC1 will ping to PC2. Okay, so PC1 will send the ping to PC2, correct? So ping is basically layer 3, okay, which uses the protocol as ICMP, and the ICMP uses the protocol number as 1, correct? So this is the basic information, okay, in regards with ping. Okay, so the ping packets look like the ping will send an echo message. Okay, so the echo message contains these basic information. Okay, so I'll show you that it looks like echo message, then it will add the source IP. Okay, so now we're taking a scenario as in PC1 is communicating with PC2. Okay, source IP, destination IP, then we'll see a protocol number, okay, then TTL value. Okay, so here what it will do is that it will add a source IP as 10.1, destination IP as 10.2, a protocol is 1 because ICMP uses the protocol number 1, the TTL value. So the TTL value is different for example, TTL value for Windows is 128, for iOS for router is 255, and for Linux it uses 64. Okay, so this is the basic of TTL. So right now we are using the value as 128, correct? So here we have the destination IP address. Okay, so this is the layer 3 packet. Okay, it reaches to layer 2. Okay, so the layer 2 is two types. Okay, one is Ethernet, okay, and serial. Okay, so for Ethernet it uses a protocol ARPA, and for serial it uses HDLC, correct? So these are the two types under layer 2. So let's see how layer 2 packet looks like. Okay, so the layer 2 packet, this contains first the packet. Okay, so packet is already added because the layer 3 information. Now it has Ethernet header, correct? Then it will have source MAC address, then destination MAC address, okay, then type code it has. Okay, so we have the packet here, Ethernet header will be added, source MAC address we are taking as AA because this is of PC1. Destination MAC address, we don't have destination MAC address because what happened, while a ping is sent to the switch, okay, the switch will do a broadcast, okay, to router 1 and to PC2. Okay, so then router 1 will drop it because he said it does not have it. Okay, then nobody has the switch also does not have the MAC address for PC2, correct? So if the MAC address is incomplete, then what it will do is it will generate ARP protocol. Okay, so let's check it out. So this whole layer 2 will be on hold now because we don't have the destination MAC address, correct? So how ARP packet looks like, we'll see it. Okay, so ARP is basically a protocol that let's start with ARP table. So ARP table contains all the information of MAC addresses with its port numbers. Okay, so right now we say that we does not have the MAC address for PC2, correct? So how our protocol works, as in it will take source IP, okay, destination IP, source MAC, destination MAC, and OP code. So OP code is two types. Okay, if it is request, then the code is 1. If it's reply, then it's 01, it's 02 for respond. Correct. So this is the basic information of ARP. Correct. Now what it will do is it has the source IP address, it has the destination IP address, it has source MAC address, but the destination MAC address does not have in the ARP table. So it will add all the zeros. Okay, OP code is 01. Okay, and now what it will do is that it add this particular information. Okay, then this is the ARP request, right? So this ARP request, when it reaches to layer 2, okay, so when it reaches to layer 2, so this is the request. Okay, then it add the source MAC address as AA, correct. Then destination MAC address does not have, so under layer 2 it will add all F. Okay, then it will add the type code. Correct. So still this is broadcast because all F. Okay, so you know how packet flow works. I'll show you this also. This is layer 3, this is layer 2, this is layer 1. Okay, of PC1. Correct. On PC2, this is layer 1, this is layer 2, this is layer 3. Correct. So we have layer 3 information, it's pending. For layer 2 it's not there, the MAC address. This is pending because of MAC address. When it reaches this is completely filled, as in layer 3 information is there, but when the packet reaches to layer 2, it is still pending. Okay, so due to which ARP comes into picture. Okay, so we are ready with the ARP packet, this. Correct. Now the packet goes to layer 1. So the layer 1 is physical layer. Okay, so it works as in bits. Correct. Binary 0 1 0, it's up to the binary form. Okay, again this bits goes to layer 1 of the PC2. Correct. Okay, so when it goes to the switch, and it will check this is the broadcast, and okay, so when it see it is a broadcast, it will broadcast to entire to all the routes except it is coming from. Okay, so then it checks. When it checks, so it found that this is for PC2, so PC2 will take it. Okay, then PC2 will open it. Okay, so when the PC2 open it and founds that this is all F, okay, so it will accept it. Now it will go to the ARP. Okay, so it will, when it goes to the ARP, okay, this it founds that the destination IP is his own IP address. Okay, so when it checks that destination IP is all IP, and it will also check the OP code. Okay, so OP code is the request, so obviously means that the PC2 will see that this is a request which is made by the source IP address as written over there. Okay, so then this okay, then layer 1, correct, it opens, it goes to layer 2. Okay, and it found out that this is the all information which is needed. Okay, then what it will do is that it will first ready with the ARP packet. Okay, so it will reply as in 10.2. Correct. Then the MAC address is AB. Okay, which is of the MAC address of PC2. Okay, now 10.1 is the IP address of the destination PC1. Okay, and it is AA. Okay, and it will type code as 2, so which means that this is respond. Okay, then it will add this to layer 2. Okay, under layer 2, how does it look? As in this is ARP respond. Okay, it will add Ethernet header. Okay, then it will add the information as 10.2, correct, and it is AB. Then it write as 10.1 AA, correct, and it will give the code. Okay, so this is the ARP code, correct. Now this is the information is all ready. Okay, then correct, so these all information are ready. Now it will going to send it to PC1 again, correct. So PC1 open it, and while sending it will only send as unicast. Okay, because the ARP respond is always unicast respond. Okay, and when it is request, it is broadcast. Okay, so please keep in mind this basic information in terms of it. Okay, so when it goes to layer 1, the layer 1 will open the bits and packets. It will go to layer 2, it will check that the destination is for when it goes to the layer 2, okay, it will check that the destination MAC address it's for him only. Okay, and it will accept it. Okay, and it is OP code 2 means that this is for from PC2 only. So the PC1 will get the MAC address of the PC2. Okay, so I just want to say that this whole information takes 2 seconds. Okay, so from ICMP to get the MAC address, it will take 2 seconds. If not possible, then it will say request timeout. Okay, so this is the way the packet flow works, okay, between the PC1 and PC2. Okay, so now we're going to see that how PC1 can communicate with PC3. Okay, so here in this diagram you can see right now we have done with PC1 and PC2. Now we are working on PC1 and PC3. Okay, so for that what it will do is it has the MAC address and the IP address of PC1 and PC2. They both are done. Okay, to communicate with PC3, which is in another subnet. Okay, so to reach via, there is only option which is router 1, correct. So this is only via router 1, right. So what it will do is it will generate the ARP, correct. So the ARP it will generate, which is source IP, destination IP, source MAC and destination MAC. Okay, then OP code, correct. So the source IP is 10.1, destination IP is it will take the destination IP as the IP address of default gateway, which is 10.3. The source MAC address is AA. The destination MAC would be all zeros because this is the request. Okay, OP code is 01. Okay, so the this is the request which is sent by PC1 to PC3. Okay, so this particularly is ARP request, right. So it will send as AA, correct, and all F. Okay, and the type code, correct. So this is the request. Now this request will be broadcast, correct. When it broadcasts to router 1, the router 1 will accept it by looking at the MAC address. It will take all the F, it will see it as it is a broadcast, it will accept it. Okay, then the router 1 will reply. Okay, so it will reply as source IP as 10.3, destination IP as 10.1. Okay, source MAC is RA. Okay, I think we gave RA only for that, correct. So so it is the router MAC address, correct, and then it will the source MAC address is router, then destination MAC address. So the destination MAC address, this is sent by router 1, correct? So it is double A, which is PC1's MAC address, okay? And this is OP code 02, correct? Because this is a response, okay? While it reaches via switch, and the switch will transfer it to PC1, correct? The PC1 will accept it, the PC1 will add it. Okay, now what it will do is that the PC1 will the PC1 will generate, okay, again the PC1 will generate again a request, okay, because it has the MAC address and the IP address of router 1, correct? So the PC1 will send another request, as in having source IP address as 10.1, source MAC address is double A, okay, then destination IP is, because the router the PC wants to reach to PC3 whose IP address is 20.3, okay. So okay, and the destination MAC address it will give as router 1 MAC address, okay. So this particular packet has IP address as PC3 IP address, but the MAC address is of router 1 MAC address, okay. So when the packet reaches, it will check the source address, destination MAC address, okay. So when it reaches, it will check the layer 2 protocol, okay. Under layer 2 it will see that the destination MAC it is for router 1 only, so the router 1 will accept it. And the router 1, what router 1 will again do is that the router 1 will accept it, but the router 1 will go to layer 3 information, and it will found that the destination IP is 20.3, okay. So then the same step is performed with this only, as in between the PC3 and the router. Also there is a ARP like the ARP protocol works between them to get the IP address. So what the the router 1 will do is that the router 1 will, okay, so when this packet reaches to router 1, the router 1 will check that this is for 20.3, but the MAC address is for router 1, okay. So what the router 1 will do is the router 1 keep all the information as it is, source IP, source MAC as in PC1, destination IP is 20.3, and it will add the destination MAC address as PC3 MAC address, okay. So PC3 MAC address is with router 1, because the ARP is they already made a ARP request and ARP respond between their side, and they get the MAC address of it, okay. So the router 1, in the ARP table of router 1, it has the entry of PC3 MAC address, so it will add as AC, okay. And this router 1 will forward this particular information to PC3, okay. So then PC3 will open this packet, it will found out that the destination IP is this as the PC3 IP address only, and the MAC address is also for PC3. The PC3 will accept it, okay, and it will send a response to router 1, correct, as in by giving the same information as in source IP, source MAC, destination IP, destination MAC, okay. So the destination IP and destination MAC would be, okay. So when PC3 is replying to router 1, okay, because we can see this topology here, the PC3 will get the packet from router 1, correct. So the PC3 will reply as in source IP address as 20.3, correct. The source MAC address is AC, okay. The destination IP is 192.168.10.1 and the destination MAC. So now here the destination MAC would be router 1 MAC address, okay. So the router 1 MAC address is RA, okay. So it will add here as router 1 MAC address and send it to router 1, okay. So when router 1 receives it back, router 1 check that the destination IP is 10.1 which is inside it, okay. Then it will check the MAC address of router 1, okay. So the router 1 will again change the packet, okay, as in putting the source IP address, destination IP address, source MAC and destination MAC, Okay, so the source IP address it will put is 20.3. Okay, then destination IP address is 10.1. Correct. The source MAC address is AC. Correct. And the destination MAC address is AA. Okay, so this is the packet. The router 1 will send to the switch, and the wire switch will forward to the PC1.